Hi, in this video we're going to be looking at the projectile motion worksheet. And so we're going to talk about projectile motion. Now remember, projectile motion is anytime we launch something up into the air at an angle. So projectile motion is unique in the fact that it's two-dimensional motion. In one dimension, up and down, there's an acceleration. That acceleration being the acceleration of gravity, 9.81 meters per second squared here on Earth, da-da-da-da. In the other direction, horizontal, we're going to go with no acceleration. We're going to ignore friction for right now. And so therefore, when this thing gets thrown horizontally, whatever velocity it has when it starts off is going to stay that the entire time. As opposed to vertically, where when it gets tossed up in the air, its vertical velocity will change. Okay, so whenever we get these problems, the number one thing to remember, first and foremost, draw yourself a picture. Again, you probably heard me say it a couple dozen times. You're going to hear me say it a lot more. If you can draw the picture and know what's going on, then you are much more likely to actually get the problem right. So we look at this, a ball thrown horizontally at a speed of 10 meters per second off of a 20-meter tall building. So what I'm actually going to do is I'm going to draw a building. And I know the height of this building, which I'll put in red, is 20 meters. The ball's being thrown off at a velocity, so I'll put that in orange. Horizontal velocity. There's my VI, is going to be 10 meters per second. And really, that's all they give me. But I know that since this thing is going through the air, as it's going here on Earth, it's going to undergo projectile motion. So it's going to look something, let me make it a little prettier. It's going to look something like that. It's going to follow that parabolic path. As soon as I see this, that's when I start wanting to use the chart. Now, the chart is another way of doing our guess, or the goo part of our guess. So if I put in the chart here, remember we talked about we have horizontal and we have vertical. Those are our two different dimensions. This thing we mentioned is going horizontally and vertically, but those can be analyzed independently with each other. With the thing that goes back and forth is time. Time is the one thing that links these two motions together. Now, horizontally, you can know how far it moves, and we'll call that dx. Vertically, you can know how far it moves. We'll call that dy. Now, again, I'm a big, huge fan of subscripts because I know that we have a horizontal distance and a vertical distance. I need some way to distinguish between the two. I don't want to just leave it as d, so I put a d sub x dimension for the horizontal, x direction, and dy in our y direction. I can know the initial velocity. In the initial velocity, I might have one horizontally, I might have one vertically. So I need a way to distinguish this, so I do a VIX to do the horizontal velocity. VIY is my vertical velocity, initial. I could have a final velocity horizontally. So that'll be a VFX, a final velocity vertically. That'll be VFY. And acceleration, horizontally, acceleration vertically. Now, this is something that we'll use the chart, and again, if anybody makes a jump to AP next year, we'll use this chart not just for projectile motion, but for any two-dimensional motion kind of thing. In our situation, with projectile motion, we're going to ignore air resistance, and so horizontally, this acceleration is always going to be 0 meters per second squared. There's going to be no change in velocity, which also means that these two velocities are going to be the exact same. Initial velocity, final velocity are going to be the same. Now, at this point in time, you're like, well, wait. After it hits the ground, its velocity has changed. Projectile motion only deals with it once it leaves my hand when I throw it, and up until the point when it hits the ground. Before it leaves my hand, that's a different motion, a different way to analyze it, and after it hits the ground, it's no longer projectile motion, so we can't use this chart. Now, the one thing that goes on both sides, or can be used on both sides, is time. And so when I do this, time equals, I put time right smack dab in the middle here, okay? And the reason why I make this chart, and I think I made a big deal of this in the Nearpop when we won the video, is that because the horizontal and vertical motions are separate, you can't use one to solve for the other. So I put this line right down here to remind myself that if I'm on the vertical side, let's say I want to find something vertically, I can only use vertical information to solve for it. If I want to find something horizontally, I can only use horizontal information to solve for that. The one exception is time. Time is the one thing that can go on both sides, because as this thing goes through the air and as it falls down, it's going to take that amount of time, and during that same amount of time, it's going to be moving forward. Okay, so this is our chart. Oh, the other thing we're going to put, since we're here on Earth, this acceleration vertically is 9.81 meters per second squared down. And I put that down there to remind me that the acceleration of gravity is going down, and we'll talk about that in a little bit. Okay, so now this is where I'm going to start every single time. This is my chart to do the projectile motion problems. From there, I start filling in stuff I know. You're thinking, okay, well, you don't know a heck of a lot. You know that it's going to go 20 meters down. 20 meters, that's a distance. It's got to be dy, though, because it's vertically 20 meters, not horizontally. So dy is going to be 20 meters. And I'll put that in red. And since it's going to go 20 meters down, I put in the down there. It's falling down 20 meters. Okay. The other thing I know is it's being thrown horizontally at 10 meters per second. I've got my meters per second here. So my VIX and my VFX, they're both going to be 10 meters per second. And you're thinking, okay, well, that's it. Does he know anything else? No. But there's something hidden in here. Because this object is thrown horizontally, I'm not throwing it up. I'm not throwing it down. So that tells me that my initial vertical velocity is 0 meters per second. It's not being thrown up, not being thrown down. So anytime you see it's being thrown horizontally, you can put your VIY as being 0 meters per second. Okay? So from that, really, that's all our givens. Okay? We know our acceleration, we know initial horizontal velocity, we know the distance is going to fall, we know initial vertical velocity, and we know the acceleration. So now, the first thing we're going to solve for, and this should be always the first thing you solve for. If it's not given, you should always solve for the time of flight of the ball first. And you're thinking, okay, well, how do I do that? Well, it's the exact same thing as before. You have information. You have to go find an equation to do it. Now, a lot of people come through and say, well, wait, I can find this, if I use time, maybe I can use VIX, maybe I can use this equation, VF equals VI plus A times T. And I'll ask you, okay, great, you want to use that, what side do you want to use that with? You have to pick either horizontal or vertical, because you can't mix and match the two of them. Okay, so if I want to use horizontal here, this is going to be 10, I'm not putting in 10 plus 0 times T, and you're like, oh, that doesn't solve it. So that doesn't work. And I know I ripped through that, but if you try it, if you try and use the horizontal side, you'll see that you get 0 equals 0, which is a good thing, but it doesn't help us solve for t. So what I want to do is I want to use my d equals VIT plus 1/2 AT squared. The reason I use that is because I want to solve for time. So the equation I have to use for time has to have time in it. This works because, and I'm going to put a little dy, VIY, AY. I'm going to use the vertical side. I've got 20 meters. My initial velocity is 0 meters per second plus 1/2 of 9.81 meters per second squared times t squared. Now the 0 meters per second times t, that goes away. So I've got 20 equals 1/2 of 9.8 meters per second squared times t squared. And so when I solve for time, I'm going to find out the time is going to be 2.02 seconds. Now, if this equation gives you problems, come see me about this, because I can teach you how to solve it. There's a couple different ways you want to do it, but it's basically algebra rules, and whatever you do one side, you have to do the other. We want to get t all by itself, so we have to get rid of the 1/2 of the 9.81 first, and then we have to take the square root to get it from t squared to t. Okay, so once we know the time is 2.02 seconds, well, that now becomes part of our given. So now the next piece is that we want to find the vertical speed the ball hits the ground with. Well, vertical speed is VFY. So I'm going to find VFY. So I'm going to use VF equals VI plus A times T. And since I want to know final vertical velocity, this is VFY, VIY, and AY. So my VFY, that's what I'm looking for. VIY, oh, that's 0 meters per second. Plus acceleration, 9.81 meters per second squared, down, times T of 2.02 seconds. And so when I get that VFY, that's going to equal 19.8 meters per second. So 9.81 times 2.02. Now the last thing I want to know is, what's the horizontal distance? What distance does this thing travel horizontally? So that's my dx. That's how far it has to go. So the equation I'm going to use here, I'm going to use the same equation, the same distance equation. I'm going to use dx equals VIX times t plus 1/2 AX t squared. And so dx, that's what I'm looking for. VIX, oh, that's 10 meters per second. Times t, 2.02 seconds, because the time it's going forward is the same as the time it takes for it to fall down, plus 1/2 of 0 meters per second squared times 2.02 seconds squared. And that was kind of overkill because anything times 0 is 0. So my dx becomes 20.2 meters. And so this thing is going to go forward 20.2 meters. It's going to stay in the air for 2.02 seconds, and it's going to hit with a speed of 19.8 meters per second vertically. Okay, so let's take a look at the next one. A ball is thrown horizontally from the building that's 35 meters high. If the ball lands 20 meters horizontally away from the base of the building, what was the initial horizontal velocity of the ball? So I'm going to do it again. I'm going to draw a picture. Boom. I've got this ball. I know that this is 35 meters high, so I know that this is 35 meters. I know the ball is being thrown horizontally, but I don't know what velocity. I know VIX is question mark, but I do know that this thing is going to go like this, parabolic motion. So I'm going to make my chart. Oh, the other thing I know too, I know that it's going to go 20 meters. It's going to land 20 meters away. So I make my chart. Oops, let me make this black. I don't know why it didn't jump before. Oh, there we go. There we go. So make my chart. I've got my horizontal side, my vertical side. dx, this time I know it. It's 20 meters. VIX and VFX, those are the same thing, but I don't know what they are yet. This is my question mark. My AX is going to be 0 meters per second squared because we're ignoring air friction. My DY, that's 35 meters. My VIY, that's going to be 0 meters per second because, again, it's thrown horizontally, so it's not being thrown up, it's not being thrown down. VFY, don't know. Acceleration, vertically, is 9.81 meters per second squared down. Ball's going down, so hey, I'm good. So now, I don't know time. All right, so again, going back to our rule of thumb, if you don't know time, that should always be the first thing you solve for. So let's go back to our problem. We don't know time, so let's go solve for time. Let's use the vertical side, dy, VIY times t, plus 1/2 AYT squared. So 35 meters is equal to VI, oh, that's 0 meters per second, times t, plus 1/2 of 9.81 meters per second squared, times t squared. And so I can solve this. This goes away. T is going to be equal to 2.67 seconds. Again, if you struggle with getting this, come see me. I can teach you how to do it. Okay? So now I know that my t is 2.67 seconds. So now I'm trying to find my VIX. I can go back and say, all right, well, wait, I do know that horizontally, dx equals VIX times t plus 1/2 AXT squared. So dx, that's 20 meters, is equal to VIX, oh, I want that, times t, which is 2.67 seconds, plus 1/2 of, oh wait, AX is always 0, so this whole thing goes away. And so my VIX kicks out to be 7.49 meters per second, or 7.5 meters per second. You could round to there. Okay. All right. Now, I do have a couple people, and I'm just going to throw this over here. People in the past are going to say, wait, do I have to use this equation? Since I know the acceleration is 0, couldn't I just use that the V average is equal to dx over t? And the answer is yes, because since this is constant, this is basically Vx average. So you don't have to have this. The reason why I teach it, though, is that I'm kind of like setting my AP crew up so that they remember this for next year, because we will deal with two-dimensional motion, and then you will have acceleration in the horizontal, and this chart is really, really good for analyzing that. But if you want to use this, you're more than welcome. In this case, the Vx would have been 20 meters divided by the 2.67 seconds, and you still would have gotten the 7.49. All right, and our last one is a little bit different. The soccer ball is kicked from the ground level with a speed of 30 meters per second and an angle of 30 degrees to the horizontal. We want to find the maximum height of the ball, the time of flight of the ball, and the range of the ball. Okay, so again, I'm going to start off with a picture. So here's my soccer ball, and for those of you that are soccer players, I apologize. This is a really bad soccer ball. You get the idea, though. And I am kicking this. And I don't know why it didn't jump into a different color, but we're trying it again. 30 meters per second at a 30-degree angle. And so when this happens, this thing, and I'll put it in, is going to go, oops, that's kind of a bad picture. Hang on one second. It's going to go boom, like that, up and back down again. Parabolic motion. Okay, so if we know it's parabolic motion, we've got to do our chart. My computer's getting a little funky. I've been doing this too long. Doesn't want to change colors really quickly. I think it's starting to overheat a little bit. But anyways, I still got to do my chart, horizontal, vertical. And so I'm going to have a dx and a vix and a vfx, and an ax is always going to be 0 meters per second squared because ignoring friction. Vx, vfx, the same thing. dy, viy, vfy. And AY is going to be that 9.81 meters per second squared down. Awesome. And then I've got time. And now I go, great. So I start filling stuff in. And I say, all right, well, I don't know how forward it goes. So dx is nothing. Vx, vfx, horizontal velocity. Well, I know that my initial velocity here is 30 meters per second. There we go. But is that horizontal? The answer is no. Was it vertical? The answer is no. So we can't fill out anything on this chart right now because I don't know horizontal initial velocity. But remember our golden rule. Anytime you have a vector acting at an angle, we need to break it up. And so I'm going to take my 30 meters per second. Again, not drawn to scale anymore because I'm getting kind of ugly here. There we go. So 30 meters per second at 30 degrees. And I'm going to break that up into a piece that goes horizontal. So, and a piece that goes vertical. Oops, that's supposed to be green. Give me 1 second. There we go. Now, when I'm breaking up an initial velocity, so this is VI. When I break that up, this orange piece will be VIX because I'm breaking up my initial velocity into a horizontal and into a vertical piece. VIY. My right angle is still right here. And so I can use SOHCAHTOA. Now, so when I do that, I can take the cosine of 30, multiply that by my 30 meters per second, and so I get that my horizontal velocity is basically 26 meters per second. I mean, when you do it, it's 25.98. I'm going to round that to 26. I'm not carrying out the 0.98 piece. It'll be fine. The VIY, I'm going to use sine for that. That's going to give me 15 meters per second. So now I can start filling in my stuff. My VIX, my initial velocity horizontally, that's the 26. And my VIY, that's my initial vertical velocity, is 15 meters per second. Up. As soon as I write that up, I go, uh-oh. My vertical velocity is up. My acceleration is down. I have two things going in opposite directions. Something has to be negative. And so right then and there, I am going to turn and make my acceleration, I'm going to put this in purple, make my acceleration of gravity negative. Once that happens, I realize, ooh, shoot, okay, now my acceleration has to be negative because we have things going opposite direction. I'm making up positive and down negative. Okay, so I'm good, right? Life is awesome. I still don't have enough to solve for anything yet. But I do remember that we did talk about the fact that if you throw something up in the air, it has an initial velocity. As it starts to rise up, gravity's acting on it, trying to slow down, slow down, slow down until it gets to the very top. And when it gets to the top, it will stop. And so my velocity at the very top, Vy top, is equal to 0 meters per second. So I can put that my VFY at the halfway point is equal to 0 meters per second. Now, this works because the ball is starting and ending at the same level. And that'll be the case for our problems. Okay, so if we look here, okay, when we kick the ball, it starts on the ground. It's going to end on the ground, and there's a little dip in there. But since it starts and ends at the same level, we're fine. We don't have to worry about it, okay? Because the time it takes to go up is going to equal the time it takes to go down. So the final velocity at the halfway point is going to be 0 meters per second. Once I find that, I can use that to solve for time. So my VFY is equal to my VIY plus A times T. Because remember, I always want to solve for time first. You don't know time, solve for it first. So VFY is 0 meters per second. That's at the halfway point. VIY is 15 meters per second. Acceleration is a negative 9.81 meters per second squared. And I got to have the negative there. Otherwise, my time is going to be negative, and that would be bad. You don't want to go back in time when you kick a soccer ball. So when we do that, we find out that the time is 1.53 seconds. Now, this is the time it takes to get to the halfway point. So this is T half. And so T half is 1.53 seconds. And as long as I'm landing back down at the same level, the time it takes to go up is the time it takes to go down. So my T total is going to be 3.06 seconds. All I did was just double it. Okay? So now I have the time of flight of the ball. It's 3.06 seconds. I want to find the maximum height of the ball. Well, the ball's going to get to its maximum height at the halfway point. So I can use my equation. Actually, I'm going to use a different equation here. I'm going to use VF squared. Kick that up, maybe. VF squared equals VI squared plus 2AD. Now, this is not the only way to do this problem, but it's one that I'm going to pick on first. So VF at the top, at the halfway point, that VF is 0 meters per second. Don't forget to square it. My initial velocity vertically is 15 meters per second. Don't forget to square it. Plus 2 times a negative 9.81. You got to have the negative. Otherwise, your distance is going to be negative when you do it. And that's a problem. You don't want to throw a ball up and have its maximum height be negative. So you got 15 squared. And we're going to divide that by 2 times 9.81. And I just find that my D, this is dy, because this is y. is equal to 11.46. So I'm going to put it as 11.5 meters. That's its height, that's its d, that it moves when it gets to that halfway point, when it gets to the top. Because remember, at the top, it had to stop. So dy half is equal to 11.5 meters. That's the height it gets to at the halfway point. And the last one, the range of the ball. Range is another way of saying dx. And so if I want to solve for dx, I'm just going to go back and I'm going to use my original one. Dx is equal to Vix times t plus 1/2 axt squared. So dx is equal to the 26 meters per second times my 3.06 seconds. Now for this one, I have to use the whole time because the thing is going to be moving forward the entire time it's in the air. Plus 1/2 0 second squared times 3.06. It doesn't matter because all that's 0, so that goes away. So that gives me that my dx, my range, is going to be 79.5 meters. So 79.5. All right, so I hope this helps. And if you have any questions, again, like with the math of this, sometimes it gets a little tricky. So if you have issues, come see me. Everybody have a great day. We'll see you. Bye.